All right. This first set of problems are from the PSAT review day back when we did PSAT. I do expect you guys to do all of these problems algebraically, and since we already did these problems, they should be a review. Number one says, what's the remainder when x cubed minus 1 is divided by x plus 2? Use the remainder theorem. So if I'm using the remainder theorem, I'm going to plug in -2 for x and evaluate, which gives me 9. Number two, the function 2x cubed, 2x to the fifth minus 13x to the fourth plus 22x cubed minus 187x squared minus 160x plus 336 has x minus 7 and x plus 4i as factors. What is the total number of real roots of f of x? Now, you could graph this on the calculator, but these are pretty big numbers, and they gave you these big numbers because if you were to put this into the calculator, it's going to take up most of your time. Whereas if you know that if you have imaginary numbers, they come in pairs. So that's 2 already, 2 imaginary pairs. And then if by FTOA, fundamental theorem of algebra, if you have an exponent of 5, you should expect 5 roots. Well, I already have 2 imaginary roots. I have this root right here. So if I have 2 imaginaries, I should have 3 reals. 3, the graph of the function has a 0 of -1. What are the other zeros of the function? So if I have a 0 at -1, I'm going to use synthetic division to figure out what my other 2 roots are. I'm left with x squared plus 2x minus 4 is equal to 0. And then I am going to use the completing the square method, or you guys can use quadratic formula, even though we both know completing the square would be much efficient and much faster to figure out what your vertex form is, aka x plus 1 squared minus 5 is equal to 0. And then if I were to solve it, I get x is equal to -1 plus or minus root 5, which is C. 4, which expression is equivalent to this lovely thing right here? -2x minus -3x is an x. And then -37 minus -40 is a positive 3. So you have 1 plus x plus 3 out over x squared minus 3x minus 40, which is A. You want to factor completely for number 5, so you need to think about what the GCF of 48 and 243 is. And if I recall, pretty sure your GCF was 2, maybe 6. Not 6, 3. Yeah. So 3x was your GCF, so 16x squared minus 81y squared. You're going to get 3x, 4x plus 9y, 4x minus 9y. If k is positive, what's the effect of the graph? Well, as k increases, it gets skinnier, so it's a vertical stretch. Number 7, what's the value of h of -4 plus 3 times h of -2? So I'm going to find h of -4, and I'm going to plug it into the top solve function because that's what it satisfies. That's going to give me negative 13. And then I'm going to plug in h of negative 2, which is the second subfunction. So 30 minus 3 times 4, or 30 minus 12, or 18. So I get negative 13 plus 3 times 18, or 54. 54 minus 13 is 41. So the value is 41. B says, is h of h continuous at x is equal to negative 4? So what you want to do is plug in x is equal to negative 4 for both the top and the bottom. So on the top, I already know that it's negative 13. On the bottom, it has to be a negative 13 for it to be continuous. If it's not, then it's not continuous. So here, what I'm going to do is plug in negative 4. So 3 times 16 is 48. It's going to give me negative 18. So it's not continuous at negative 4 because negative 13 is not the same thing as negative 18. So this was problem set, well, PSAT review day.